Picture this. Right now, as you're listening to these words, the atoms in your body aren't sitting still in fixed positions. They're existing in what physicists call superposition, occupying multiple states simultaneously until something forces them to choose. The chair you're sitting in, the device you're listening on, even the thoughts flowing through your mind, all emerge from a quantum realm where reality as we know it simply doesn't exist until we look. Welcome to a journey into the heart of quantum mechanics, where the very act of observation creates the world around us. I'm here to guide you through one of the most profound discoveries in human history, a revelation so strange that even Einstein called it spooky. We're going to explore how modern physics has revealed that reality, as you've always understood it, might be nothing more than an elaborate illusion. Taishi, take a deep breath and settle in. What we're about to discover together will challenge everything you thought you knew about existence itself. Let me start with something that might sound impossible. The screen you're looking at right now doesn't actually exist in the way you think it does, neither does the room around you or the ground beneath your feet. According to quantum physics, these things exist only as waves of probability until the moment you observe them. Before that moment, they hover in a ghostly state of pure potential. This isn't philosophy or mysticism. This is hard science, verified in laboratories around the world, thousands of times over. The implications are so revolutionary that they forced us to completely reimagine what we mean when we say something is real. To understand how we arrived at this startling conclusion, we need to journey back to the early 20th century, when scientists first began peering into the atomic world. What they discovered there defied every assumption about reality that humans had held for millennia. The story begins with a simple question that haunted physicists over 100 years ago. Light, they wondered, what exactly is it? For centuries, scientists had debated whether light behaved like a wave, rippling through space like water across a pond, or like particles, tiny bullets of energy shooting through the void. The answer, as it turned out, was both, and neither, and something far stranger than anyone had imagined. When physicists conducted what's now known as the double slit experiment, they discovered something that shattered our understanding of reality. They fired individual photons of light through two narrow slits cut into a barrier, expecting each photon to pass through one slit or the other, like a marble rolling through one of two doorways. Instead, something impossible happened. Each single photon somehow passed through both slits simultaneously, creating an interference pattern on the screen behind, as if it had interfered with itself. The photon existed in what physicists call superposition, occupying multiple states at once until it struck the detector screen. But here's where it gets truly mind-bending. The moment scientists tried to observe which slit each photon actually passed through, the interference pattern vanished. The photons suddenly began behaving like ordinary particles again, each going through one slit or the other, never both. The act of observation itself was changing the fundamental nature of reality. As you absorb this idea, notice how it might apply to your own experience. How many times have you felt that the simple act of paying attention to something seemed to change it? This quantum principle, operating at the most fundamental level of existence, might be echoing through every layer of reality, including your own consciousness. This phenomenon, known as the observer effect, suggests something profound about the relationships between consciousness and the physical world. It implies that there is no objective reality independent of observation. The universe, it seems, exists in a state of pure potential until someone or something looks. The implications of the double-slit experiment rippled through the scientific community like an earthquake. If a single photon could exist in multiple states simultaneously until observed, what did this say about everything else in the universe? Were atoms, molecules, even entire objects existing in superposition until measured? This led physicists to what's known as the measurement problem, one of the deepest puzzles in quantum mechanics. The problem is deceptively simple to state but impossibly difficult to solve. When exactly does a quantum system stop existing in superposition and collapse into a single definite state? The mathematics of quantum mechanics, described by the Schrödinger equation, suggests that quantum systems should remain in superposition indefinitely unless something causes them to collapse. But what constitutes a measurement? Does it require a conscious observer, a measuring instrument, any interaction with the environment? Consider the famous thought experiment proposed by physicist Erwin Schrödinger. Imagine a cat sealed in a box with a device that has a 50% chance of releasing poison based on the decay of a single radioactive atom. According to quantum mechanics, until someone opens the box to look, the atom exists in superposition, both decayed and not decayed. This means the cat should be both alive and dead simultaneously. The absurdity of this conclusion troubled Schrödinger, who proposed it to highlight what he saw as a flaw in quantum theory. But decades of experiments have confirmed that quantum superposition is real. The question remains, at what point does the quantum world give way to the classical world we experience? Some interpretations suggest that consciousness plays a direct role in collapsing quantum states. Others propose that any interaction with the environment, conscious or not, causes collapse. Still others argue that no collapse occurs at all, and that all possible outcomes exist simultaneously in parallel universes. The most widely accepted interpretation of these quantum mysteries emerged from discussions between physicists Niels Bohr and Werner Heisenberg in Copenhagen during the 1920s. The Copenhagen interpretation, as it came to be known, offers a radical solution to the measurement problem. According to this view, quantum systems don't have definite properties before measurement. The wave function that describes a quantum system isn't a description of physical reality, but rather a mathematical tool for calculating the probabilities of different measurement outcomes. Reality, in this interpretation, is created by the act of measurement itself. This interpretation suggests that asking what a quantum system is like before measurement is meaningless. It's like asking what colour Wednesday is or what sound silence makes. The question itself is based on faulty assumptions about the nature of reality. Bohr famously declared, "There is no quantum world. There is only an abstract quantum physical description." It is wrong to think that the task of physics is to find out how nature is. Physics concerns what we can say about nature. This perspective represents a fundamental shift in how we think about physical reality. Instead of viewing physics as the study of how things really are, the Copenhagen interpretation frames it as the study of what we can know about things through measurement and observation. The implications are staggering. If the Copenhagen interpretation is correct, then objective reality, independent of observation, simply doesn't exist. The universe exists only as a collection of potential outcomes until consciousness or measurement devices force it to choose specific realities. Take a moment to consider what this means for your daily experience. Every time you look at something, you might be participating in the creation of that reality. The tree falling in the forest doesn't make a sound unless someone is there to hear it, not because sound requires ears, but because the tree itself might not have a definite state of fallen or standing until observed. Not all physicists accepted the Copenhagen interpretation's radical implications. In 1957, physicist Hugh Everett III proposed an alternative that seemed even more fantastic. Instead of quantum states collapsing upon observation, Everett suggested that all possible outcomes of any quantum measurement actually occur, but in separate parallel universes. According to the many worlds interpretation, when you measure a quantum system that could have two possible outcomes, the universe splits into two branches. In one branch, you observe outcome A. In the other, you observe outcome B. Both versions of you are equally real, but they exist in parallel realities that can never interact. This interpretation preserves the mathematical elegance of quantum mechanics by never requiring wave function collapse. The Schrödinger equation continues to evolve smoothly, describing an ever-branching tree of parallel realities. Every quantum measurement, every random event, every choice splits the universe into multiple versions. The implications are mind-boggling. If many worlds is correct, then there are countless versions of you reading these words right now. In some universes, you decided not to listen to this video. In others, quantum fluctuations led to slightly different arrangements of atoms in your brain, creating slightly different thoughts and experiences. This interpretation suggests that reality isn't singular, but rather an infinite collection of parallel realities, all equally valid, all equally real. You experience only one branch of this cosmic tree, but all the others exist just as surely as the one you inhabit. The strangeness of quantum mechanics doesn't end with superposition and measurement. Another phenomenon, quantum entanglement, reveals that reality is not only observer-dependent, but also fundamentally non-local. This means that particles can instantaneously affect each other across vast distances, seemingly violating the speed of light limit established by Einstein's relativity. When two particles become entangled, they form a single quantum system, even when separated by great distances. Measuring one particle instantly determines the state of its partner, no matter how far apart they are. Einstein famously called this spooky action at a distance and argued it proved quantum mechanics was incomplete. But experiments have repeatedly confirmed that quantum entanglement is real. In 1964, physicist John Bell developed a mathematical test that could distinguish between quantum mechanics and any theory based on local hidden variables. Bell's theorem showed that no physical theory based on local hidden variables can reproduce all the predictions of quantum mechanics. Subsequent experiments testing Bell's inequalities have consistently favoured quantum mechanics over local realism. This means that either the world is not real in the way we think it is, or it is real but non-local, in a way that defies our everyday understanding of space and causality. The implications are profound. If entangled particles can instantaneously influence each other across cosmic distances, then the universe must be fundamentally interconnected in ways that transcend our classical notions of separate objects existing in space and time. As you contemplate this, consider the possibility that everything in the universe might be entangled in some subtle way. The atoms in your body were once part of ancient stars. The quantum fields that give rise to matter and energy permeate all of space. Perhaps the sense of separation between self and world is itself an illusion created by our classical perspective on reality. You might wonder why, if quantum superposition is real, we don't see cats that are both alive and dead, or chairs that exist in multiple positions simultaneously. The answer lies in a process called quantum decoherence, which explains how the quantum world gives rise to the classical reality we experience. Decoherence occurs when a quantum system interacts with its environment. These interactions don't destroy superposition, but they spread the quantum information into the environment in such a way that it becomes practically impossible to observe quantum effects on large scales. Imagine a quantum system as a delicate symphony of waves, perfectly orchestrated in superposition. When this system interacts with the environment, it's like introducing random noise that drowns out the subtle harmonies. The quantum information is still there, but it's scattered across so many environmental degrees of freedom that we can no longer detect the interference patterns that reveal superposition. This process happens incredibly quickly for macroscopic objects. A dust mote floating in air loses its quantum coherence in less than a trillionth of a second due to collisions with air molecules. For larger objects, decoherence occurs even faster. Decoherence explains why quantum effects seem confined to the microscopic world, while leaving open the possibility that everything at its deepest level remains quantum mechanical. The classical world emerges from the quantum world not through any fundamental change in the nature of reality, but through our inability to observe quantum coherence in complex environmentally coupled systems. This perspective suggests that the boundary between quantum and classical reality is not fixed but depends on our observational capabilities. As our instruments become more sensitive and our isolation techniques more sophisticated, we can observe quantum effects in ever larger systems. Recent experiments have demonstrated quantum superposition in objects containing billions of atoms, pushing the boundary between quantum and classical ever further into the macroscopic realm. Throughout this exploration, we've seen how observation plays a central role in quantum mechanics. This has led some physicists and philosophers to wonder whether consciousness itself might be fundamental to the collapse of quantum states and the creation of classical reality. The idea that consciousness causes wave function collapse was seriously considered by several pioneering quantum physicists, including Eugene Wigner and John von Neumann. They proposed that only conscious observation could cause the discontinuous jump from quantum superposition to classical definiteness. However, this interpretation faces significant challenges. If consciousness is required for wave function collapse, when did collapse first occur in the universe? Did quantum superpositions persist for billions of years until the first conscious observers evolved? And what exactly constitutes consciousness? Does it require human-level awareness, or would simpler forms of information processing suffice? Most physicists today favour interpretations that don't require consciousness for measurement, viewing measurement as any irreversible interaction that leaves a record in the environment. But the question of consciousness and quantum mechanics remains open and continues to inspire research at the intersection of physics, neuroscience, and philosophy of mind. Some interpretations suggest that consciousness might not cause wave function collapse, but rather selects which branch of reality we experience in a many worlds scenario. Others propose that consciousness and quantum mechanics are both emergent properties of more fundamental information processing principles. Take a breath and consider how this applies to your immediate experience. Right now, your brain is processing quantum mechanical events at the molecular level, neurotransmitters cross synapses through processes that may involve quantum tunneling. The very thoughts arising in your awareness emerge from quantum mechanical processes in neural microtubules and ion channels. While we can't definitively say that consciousness creates reality, we can appreciate the profound mystery of how conscious experience emerges from quantum mechanical processes in the brain, and how that conscious experience seems to reveal a universe that exists only in potential until observed. If you find yourself drawn deeper into these explorations of quantum reality and consciousness, I should mention that members of our community get to experience these journeys completely ad-free, with early access to each episode 48 hours before public release. It's a way to support this work while diving even deeper into the mysteries we explore together. You can join whenever you feel ready, but for now, let's continue our journey into the quantum foundations of reality. The relationship between consciousness and quantum mechanics remains one of the most tantalizing frontiers in science. While we may not yet understand exactly how awareness arises from quantum processes, or whether consciousness plays a fundamental role in shaping reality, we can appreciate the profound mystery of existing as conscious observers in a universe that seems to require observation to become real. As we've seen, quantum physics reveals a reality far stranger than our everyday experience suggests. In the quantum realm, particles exist in superposition until measured. Reality is fundamentally non-local, and the very act of observation appears to create the classical world we inhabit. But our exploration has only just begun. In our next journey together, we'll delve even deeper into these mysteries in Something Strange Happens When You Trust Quantum Mechanics, where we'll discover how embracing quantum uncertainty might paradoxically lead us to a more profound understanding of reality than any classical physics ever could. As we venture deeper into quantum reality, we encounter something remarkable: the strange behaviors we've explored. Superposition, entanglement, observer effects aren't just abstract curiosities confined to physics laboratories. They're becoming the foundation for technologies that are reshaping our world in ways that would have seemed like magic just decades ago. Quantum computers represent perhaps the most tangible proof that these bizarre quantum principles have real-world power. Unlike classical computers that process information in definite bits of 0 or 1, quantum computers use quantum bits, or qubits, that exist in superposition of both states simultaneously. Imagine trying to solve a maze by walking through every possible path one at a time. That's how classical computers approach complex problems, testing each possibility sequentially. A quantum computer, by contrast, can explore all possible paths simultaneously, like a ghost that can walk through walls and exist in multiple locations at once. This isn't science fiction. Companies like IBM, Google, and others have built quantum computers that can perform certain calculations exponentially faster than the most powerful classical supercomputers. In 2019, Google claimed to achieve quantum supremacy, performing a calculation in 200 seconds that would take the world's fastest supercomputer 10,000 years. But here's what makes this especially profound for our understanding of reality. These quantum computers work precisely because they harness the same observer effect we discussed earlier. The moment you try to peek at a qubit to see what state it's in, you collapse its superposition and destroy the quantum advantage. The computer's power emerges from maintaining quantum systems in states that classical physics says shouldn't exist. As you reflect on this, consider how it mirrors something deeper about knowledge itself. Sometimes the act of trying to pin down exactly what we know destroys the very insights we're seeking. Perhaps there's a quantum-like quality to consciousness, where certain understandings can only exist in a state of gentle uncertainty. The implications extend far beyond computing. Quantum cryptography uses the observer effect as a feature, not a bug. Any attempt to intercept quantum encrypted messages necessarily disturbs the quantum states, immediately alerting both sender and receiver to the presence of an eavesdropper. It's as if the universe itself protects quantum information from unauthorized observation. This suggests something profound about information itself. In the quantum realm, information isn't just data to be copied and transmitted. It's a fundamental aspect of reality that follows strange rules that seem designed to preserve certain kinds of knowledge, while making others impossible to obtain without consequences. Our journey into quantum reality leads us to one of the most mind-bending proposals in modern physics, the holographic principle. This idea suggests that everything we experience as three-dimensional reality might actually be encoded on a two-dimensional surface, like a hologram projected from a distant boundary. The concept emerged from studies of black holes, those cosmic monsters whose gravitational pull is so strong that not even light can escape. Physicists Stephen Hawking and Jacob Bekenstein discovered that black holes have entropy, a measure of information content that's proportional to the area of their surface rather than their volume. This was surprising because we normally think of information as being stored throughout the volume of an object. But black holes seem to store all their information on their two-dimensional surface. This led physicists to wonder whether the same might be true for the entire universe. According to the holographic principle, all the information that makes up our three-dimensional reality, every particle, every force, every quantum state, might be encoded on a distant two-dimensional boundary that we can never directly observe. We experience three dimensions, but the fundamental reality might be a kind of cosmic hologram. This isn't just mathematical speculation. The holographic principle has led to breakthroughs in understanding both black holes and the quantum nature of space-time itself. It suggests that what we call space and time might be emergent properties arising from more fundamental information processing at the universe's boundary. Take a moment to contemplate what this might mean for your experience right now. The sensation of depth, of objects existing in front of and behind each other, might be a kind of illusion created by information processing occurring on an unimaginably distant surface. The three-dimensional world you inhabit might be no more fundamental than the three-dimensional images that emerge from a flat holographic plate when illuminated correctly. This connects back to our earlier exploration of the observer effect. If reality is fundamentally informational, encoded holographically, then observation might be the process by which this encoded information gets decoded into the classical experience we call reality. The act of measurement might be the universe reading its own holographic storage system. The quantum mysteries we've explored aren't confined to physics laboratories and cosmic phenomena. Recent discoveries suggest that life itself might harness quantum effects in ways that challenge our understanding of both quantum mechanics and biology. Consider photosynthesis, the process by which plants convert sunlight into chemical energy. For over a century, scientists assumed this process followed classical physics. Sunlight hits a chlorophyll molecule, which passes the energy along to neighbouring molecules until it reaches a reaction centre, where it's converted to chemical energy. But in 2007, researchers using ultrafast laser spectroscopy discovered something extraordinary. The energy in photosynthetic systems doesn't just hop randomly from molecule to molecule. Instead, it explores multiple pathways simultaneously in quantum superposition until it finds the most efficient route to the reaction centre. This quantum coherence persists for hundreds of femtoseconds, long enough to significantly improve the efficiency of energy transfer. Plants, it seems, have evolved to exploit quantum mechanics to harvest light with near-perfect efficiency. Even more remarkably, this quantum coherence exists in warm, wet, noisy biological environments where quantum effects should be rapidly destroyed by decoherence. Somehow, biological systems have learned to maintain and exploit quantum properties under conditions that physicists would consider impossible for preserving quantum coherence. Similar quantum effects have been discovered in other biological processes. Some researchers propose that bird navigation relies on quantum entanglement in specialized proteins in their eyes, allowing them to literally see magnetic fields. Others suggest that the sense of smell might involve quantum tunneling, where molecules are identified not just by their shape, but by their quantum vibrational signatures. If these discoveries hold up to further scrutiny, they suggest something profound. Life might not just be subject to quantum mechanical laws, it might have evolved to actively exploit quantum effects. The boundary between quantum and classical reality might be far more fluid than we imagined. As you breathe in and out, consider that the oxygen molecules entering your lungs, the chemical reactions powering your thoughts, the very processes that sustain your consciousness, might all be quantum mechanical at their core. You might not just be observing quantum reality, you might be a quantum phenomenon yourself. Having explored quantum computers, holographic universes, and quantum biology, we return to the fundamental puzzle that started our journey, the measurement problem. With all we've learned, can we now answer when and how quantum superpositions collapse into classical reality? The honest answer is that the measurement problem remains as mysterious as ever. Perhaps more so, each new discovery seems to deepen the puzzle rather than resolve it. Quantum effects in biology suggest that the boundary between quantum and classical is more fluid than we thought. Quantum computers demonstrate that we can maintain and manipulate superposition states, but only by carefully avoiding measurement. Some interpretations have gained and lost favour over the decades. The idea that conscious observation causes wave function collapse has largely fallen out of mainstream physics, not because it's been disproven, but because it raises more questions than it answers. If consciousness collapses quantum states, what exactly constitutes consciousness? Does it require human-level awareness, or would a simple thermostat suffice? The many worlds interpretation remains popular among some physicists because it avoids the collapse problem entirely. If all possible outcomes occur in parallel universes, there's no moment when superposition ends and classical reality begins. Every measurement simply splits the observer into multiple versions, each experiencing one outcome. But many worlds faces its own puzzles. How do we explain the apparent randomness of quantum measurements if all outcomes occur? Why do we experience the born rule probabilities if every outcome is equally real? And what determines which branch of reality we find ourselves experiencing? Decoherence theory provides a compelling explanation for why quantum effects are hard to observe in macroscopic systems, but it doesn't solve the fundamental measurement problem. Decoherence explains the apparent collapse of superposition without requiring actual collapse. The quantum information spreads into the environment where we can't track it, but it's still there in principle. Recent proposals suggest even stranger possibilities. Some physicists propose that space-time itself is emergent from quantum entanglement, with the classical world arising from the information geometry of quantum systems. Others suggest that consciousness and quantum mechanics are both manifestations of more fundamental information processing principles that we don't yet understand. As our understanding of quantum mechanics has deepened, a new picture of reality has emerged. Instead of thinking of the universe as made of matter and energy arranged in space and time, we might need to think of it as fundamentally informational, with matter, energy, space, and time all emerging from deeper information processing principles. This information-theoretic view of reality helps make sense of many quantum mysteries. The observer effect becomes the universe processing information about its own states. Entanglement becomes the sharing of information between distant parts of the cosmic information processing system. The measurement problem becomes a questioner about how information gets integrated and decoded into classical experience. Even the holographic principle fits naturally into this picture. If reality is fundamentally informational, then it makes sense that all the information describing a three-dimensional region could be encoded on its two-dimensional boundary, just as all the information in a computer file is ultimately encoded in a one-dimensional sequence of bits. This perspective suggests that what we call physical reality might be more like a simulation running on some cosmic information processing substrate. Not a simulation in the sense of being artificial or less real, but in the sense that what we experience as solid matter and flowing time might be emergent properties of information processing, like the graphics and sound emerging from a video game running on computer hardware. The implications are profound. If reality is fundamentally informational, then perhaps consciousness, as an information integration process, plays a more central role than we imagined, not as the cause of wave function collapse, but as the process by which the universe becomes aware of its own information content. Take a deep breath and notice how this idea resonates with your direct experience. Your thoughts, your perceptions, your sense of self all seem to emerge from information processing in your brain. If the universe itself is an information processing system, then consciousness might be the universe's way of experiencing itself from the inside. As we near the end of our exploration, it's worth considering where these discoveries about the quantum nature of reality might lead us. We stand at a unique moment in human history, where our technology is beginning to harness quantum effects, while our understanding of quantum mechanics continues to deepen. Quantum computers may soon solve problems that are impossible for classical computers, potentially revolutionizing everything from drug discovery to artificial intelligence. Quantum sensors are already detecting gravitational waves and magnetic fields with unprecedented precision. Quantum communication networks promise perfectly secure information transfer across global distances. But perhaps more importantly, our growing understanding of quantum mechanics is changing how we think about reality itself. The classical worldview of separate objects interacting through forces in space and time is giving way to something more subtle, more interconnected, more mysterious. We're learning that observation and reality are intimately connected in ways that classical physics never imagined. We're discovering that information might be more fundamental than matter and energy. We're finding quantum effects in living systems and possibly in consciousness itself. These discoveries don't just change our scientific worldview, they invite us to reconsider our place in the universe. If reality is fundamentally quantum mechanical, then we're not separate observers looking at an independent world. We're participants in a cosmic information processing system, quantum beings in a quantum universe, consciousness arising from and contributing to the very fabric of reality itself. If you find yourself wanting to drift even deeper into these explorations of consciousness and reality. I should mention that our community members get to experience these journeys completely ad-free, with early access to each episode 48 hours before public release. It's a way to support this work while diving even deeper into the mysteries we explore together. You can join whenever you feel ready, but for now, let's continue contemplating what it means to exist in a quantum universe. What does it mean to live consciously in a universe where reality isn't real in the classical sense? How do we navigate daily life knowing that the solid world around us emerges from quantum uncertainty? These aren't just philosophical questions, they're practical challenges for anyone who takes quantum mechanics seriously. One approach is to embrace uncertainty as a fundamental feature of existence rather than something to be eliminated. Classical thinking suggests that perfect knowledge and control should be possible in principle, even if difficult in practice. Quantum mechanics tells us that perfect knowledge is impossible even in principle. Some properties of reality simply cannot be known simultaneously, no matter how sophisticated our instruments become. This quantum uncertainty isn't a limitation to be overcome, but a feature to be appreciated. It's what allows for genuine novelty in the universe. If everything were perfectly determined, there would be no room for creativity, growth, or genuine choice. Quantum uncertainty opens up space for possibility. Consider how this applies to your own decision-making. Instead of agonizing over finding the perfect choice, you might embrace the quantum perspective that some uncertainty is unavoidable and even beneficial. The future is genuinely open, shaped by both quantum randomness and the choices you make within that uncertainty. The quantum principle of complementarity suggests that some aspects of reality can't be observed simultaneously. Position and momentum, energy and time, wave and particle properties are complementary pairs that exclude each other in measurement. This might apply to other aspects of life as well. Perhaps we can't simultaneously experience complete security and complete freedom, perfect knowledge and perfect wonder, absolute certainty and genuine faith. Quantum entanglement reveals the deep interconnectedness of reality. Even when separated by vast distances, entangled systems remain correlated in ways that transcend our classical understanding of space and time. While we can't use quantum entanglement to communicate faster than light, it does suggest that the universe is far more interconnected than our everyday experience suggests. This quantum interconnectedness might manifest in subtle ways throughout reality. The atoms in your body were forged in ancient stars. The quantum fields that give rise to matter and energy permeate all of space. And the information that defines you is constantly exchanged with your environment. The boundary between self and world might be less absolute than it appears. Throughout our journey, we've returned repeatedly to the central mystery of the observer effect. The act of observation seems to play a fundamental role in quantum mechanics, yet we still don't fully understand what constitutes observation or how it creates classical reality from quantum possibility. This mystery takes on new dimensions when we consider that we, the observers, are ourselves quantum mechanical systems. Our brains process information through quantum mechanical processes. Our thoughts emerge from quantum events in neural microtubules, synapses, and ion channels. We are quantum phenomena observing quantum phenomena, consciousness arising from the very processes we're trying to understand. This creates a kind of recursive mystery. If consciousness emerges from quantum mechanical processes, and quantum mechanical processes seem to require observation to become definite, then what observes the quantum processes that give rise to consciousness? It's observers all the way down and observers all the way up. Some interpretations suggest that the universe is engaged in a kind of cosmic self-observation, with each conscious observer serving as a point where the universe becomes aware of itself. From this perspective, your consciousness isn't separate from the universe. It's one of the ways the universe experiences and understands itself. This isn't mysticism, though it may sound mystical. It's a serious attempt to understand how subjective experience arises from objective quantum mechanical processes, and how that subjective experience relates back to the quantum reality that gave rise to it. The recursive nature of quantum observation might explain why consciousness feels so mysterious. We're trying to understand the very processes that give rise to our ability to understand. It's like trying to see your own eyes without a mirror, or lift yourself up by your own bootstraps. The tool of observation is itself made of what it's trying to observe. As we approach the end of our exploration, it's important to acknowledge what we don't know. Despite decades of experimental verification and technological application, quantum mechanics remains deeply mysterious. We can calculate quantum probabilities with incredible precision, but we still don't understand why those particular probabilities rather than others, or what selects the specific outcomes we observe. The measurement problem remains unsolved. Multiple interpretations of quantum mechanics make identical experimental predictions but propose radically different pictures of reality. Some suggest infinite parallel universes. Others deny the existence of objective reality altogether. Still others propose modifications to quantum mechanics itself. These aren't just academic debates. They touch on fundamental questions about the nature of existence, consciousness, and our place in the universe. As our technology becomes increasingly quantum mechanical, and as we potentially discover quantum effects in biological systems and perhaps consciousness itself, these questions become more urgent. We may be approaching a new phase in human understanding, where the classical distinction between observer and observed, between mind and matter, between subjective and objective, begins to break down. The quantum revolution that began over a century ago may still be in its early stages. Some physicists propose that consciousness and quantum mechanics are both emergent properties of more fundamental information processing principles. Others suggest that space and time themselves are emergent from quantum entanglement. Still others propose that what we call reality is a holographic projection from a higher dimensional information processing substrate. These ideas remain speculative, but they point toward a future where our understanding of reality may be as different from current quantum mechanics as quantum mechanics is from classical physics. We may be on the verge of discoveries that will make today's quantum mysteries seem as quaint as yesterday's debates about whether atoms really exist. What makes quantum mechanics so compelling isn't just its experimental success or technological applications, but the way it confronts us with eternal questions about the nature of reality, consciousness, and existence itself. These are questions that philosophers have pondered for millennia, but quantum mechanics gives them new urgency and precision. Is reality fundamentally mental or physical? Quantum mechanics suggests that the distinction might be meaningless. Observation seems to play a fundamental role in creating physical reality, but observation emerges from physical processes in the brain. Mind and matter appear to be two aspects of a more fundamental reality that transcends both. Is the universe deterministic or random? Quantum mechanics suggests that randomness is fundamental, not just a reflection of our ignorance, but this randomness follows precise statistical laws that allow for extraordinarily accurate predictions. It's as if the universe is both perfectly lawful and completely unpredictable. Are we separate individuals or part of a larger whole? Quantum entanglement reveals connections that transcend space and time, suggesting that the universe might be far more unified than our classical experience suggests. Yet we each have unique perspectives and experiences that seem irreducibly individual. These paradoxes don't have easy answers, and perhaps that's the point. Quantum mechanics teaches us that reality is subtler, stranger, and more wonderful than our classical concepts can capture. It invites us to live with mystery, to embrace uncertainty, and to remain open to possibilities that transcend our current understanding. As you contemplate these ideas, notice how they might already be manifesting in your direct experience. The uncertainty principle might explain why trying too hard to control outcomes sometimes backfires. The observer effect might illuminate why the act of paying attention changes what we attend to. Quantum entanglement might reflect the deep connections you feel with others, with nature, with the universe itself. Our exploration of quantum reality has taken us from the double slit experiment to quantum computers, from the measurement problem to the holographic universe, from quantum biology to the nature of consciousness itself. We've seen how the act of observation creates reality, how information might be more fundamental than matter and energy, and how the universe might be engaged in a kind of cosmic self-observation. Yet for all we've discovered, the deepest mysteries remain. We still don't know why the universe appears to be fundamentally quantum mechanical rather than classical. We don't understand how subjective experience arises from objective quantum processes. We can't explain why observation seems to play such a central role in determining what's real. These mysteries aren't problems to be solved once and for all, but invitations to ongoing exploration and wonder. Each new discovery in quantum mechanics opens up new questions, new possibilities, new ways of understanding our place in the cosmic order. The quantum revolution has shown us that reality is far stranger and more wonderful than our ancestors ever imagined. It's revealed a universe that's fundamentally interconnected, where observation and reality are intimately related, where consciousness might play a central role in the very fabric of existence. But perhaps most importantly, quantum mechanics has taught us humility. It's shown us that our classical intuitions about reality are limited, that there are aspects of existence that transcend our everyday concepts, that the universe is under no obligation to conform to our expectations about how things should work. This humility opens up space for wonder, for mystery, for the recognition that we're part of something far greater and stranger than we can fully comprehend. We're conscious observers in a quantum universe, participants in a cosmic story that's still being written, quantum beings discovering our own quantum nature. As we've seen throughout this journey, the implications of quantum mechanics extend far beyond physics laboratories. They touch on fundamental questions about reality, consciousness, and existence itself. They invite us to reconsider our place in the universe and our relationship to the reality we observe and participate in creating. The quantum universe isn't just a scientific theory, it's a new way of being in the world. It invites us to embrace uncertainty as a creative force, to recognize our deep interconnection with all of existence, and to approach reality with a sense of wonder and humility appropriate to the magnificent mystery of which we're part in our continuing exploration of these profound mysteries. We'll delve deeper into what happens when we fully embrace the implications of quantum mechanics in something strange happens when you trust quantum mechanics, where we'll discover how accepting quantum uncertainty might paradoxically lead us to a more profound understanding of reality than classical certainty ever could. For now, rest in the wonder of existing as a conscious observer in a universe where reality emerges from the very act of observation itself. You are both the observer and the observed, a quantum phenomenon contemplating its own quantum nature, consciousness arising from and contributing to the magnificent mystery of existence itself. As we drift deeper into the quantum realm, we encounter perhaps the most profound mystery of all, the nature of time itself. In our classical experience, time flows like a river, carrying us inevitably from past through present toward future. But quantum mechanics reveals something far stranger. At the quantum level, time doesn't flow at all. It simply is. This revelation emerges from the deepest mathematics of quantum theory. The Wheeler-DeWitt equation, sometimes called the equation of quantum gravity, describes the quantum state of the entire universe. But this equation contains no time parameter whatsoever. From the perspective of quantum cosmology, time is not fundamental but emergent, arising from the correlations between different parts of a timeless quantum reality. Consider what this means for your experience right now. The sense of temporal flow of moments succeeding one another might be a kind of illusion created by the way information is processed in conscious systems embedded within a fundamentally timeless quantum universe. The past doesn't exist before, and the future doesn't exist after in any absolute sense. They exist as different configurations of quantum information in an eternal timeless whole. This timeless perspective helps resolve some of the deepest paradoxes in quantum mechanics. The delayed choice experiments we discussed earlier become less mysterious when we realize that there is no absolute before and after at the quantum level. The decision to measure doesn't reach backward in time to influence the past behavior of a particle. Instead, the entire experimental setup, including both the particle's journey and the eventual measurement decision, exists as a single, timeless quantum state. Take a moment to feel into this possibility. What if the anxiety you sometimes feel about the future, or the regret you carry about the past, are based on a fundamental misunderstanding of time's nature? What if past, present, and future all exist simultaneously in a timeless quantum reality, and consciousness creates the illusion of temporal flow by moving its focus through different aspects of this eternal whole? Some interpretations suggest that consciousness itself might be the process by which the timeless quantum universe experiences temporal flow. From this perspective, you are not moving through time so much as time is flowing through you, with each moment of awareness representing a cross-section through the eternal quantum state of all that is. To understand quantum reality at its deepest level, we must venture into the realm of quantum field theory, where even empty space reveals itself to be alive with invisible activity. What we call particles, electrons, photons, quarks are not actually things at all, but rather excitations in underlying quantum fields that fill all of space. Imagine space as an infinite ocean, not of water, but of pure potential. What we perceive as particles are like waves on this ocean, temporary disturbances in the underlying field. An electron is not a tiny sphere orbiting an atom, it's a localized excitation in the electron field. A photon is not a packet of light traveling through empty space, it's a ripple in the electromagnetic field. But here's where it gets truly mysterious. Even when there are no particles present, The fields themselves are never completely still. They fluctuate constantly at the quantum level, creating what physicists call the zero-point energy of the vacuum-empty space. It turns out, is not empty at all, but seethes with virtual particles appearing and disappearing in fleeting moments too brief to observe directly. These vacuum fluctuations are not mere mathematical abstractions. They have measurable effects, like the Casimir force that pushes two metal plates together when placed very close in a vacuum, and the slight shift in electron energy levels known as the Lamb shift. The emptiness between the atoms in your body, the space between stars, the vast voids between galaxies, all buzz with this invisible quantum activity. As you sit quietly, breathing in and out, consider that the space around you and within you is alive with quantum fields dancing their eternal dance. The solid matter of your body emerges from excitations. In these fields, patterns of energy that have taken temporary form as molecules, cells, organs, and ultimately as the conscious being reading these words. This field-theoretic view of reality suggests that separation is truly an illusion. There are no discrete objects in space, only different patterns of excitation in fields that extend throughout the universe. You are not separate from your environment, but rather a temporary pattern in the same quantum fields that give rise to everything else. The implications extend far beyond physics. If consciousness emerges from quantum processes in the brain, and these quantum processes are themselves excitations in universal quantum fields, then consciousness might be a local intensification of something that exists in some form throughout the fabric of reality itself. Recent discoveries in neuroscience suggest that the brain itself might operate according to holographic principles, processing information in ways that mirror the holographic universe we explored earlier. This isn't mere coincidence, but might reflect deep connections between consciousness and the quantum structure of reality. Neurophysiologist Carl Pribram proposed that memories are not stored in specific locations in the brain, but are distributed holographically throughout neural networks. Just as each piece of a holographic plate contains information about the entire image, each part of the brain might contain information about the whole of experience and memory. This holographic model explains many puzzles in neuroscience. How can the brain continue to function even when large portions are damaged? How can memories remain intact despite the constant turnover of brain cells? How does the brain integrate information from millions of neurons into unified conscious experience? If the brain operates holographically, then consciousness might not be localized to any particular region, but might emerge from the interference patterns created by quantum processes distributed throughout the nervous system. Your sense of being a unified self, experiencing a coherent world, might arise from quantum interference patterns in the holographic storage and processing medium of neural microtubules. Some researchers propose that these microtubules, the structural elements within brain cells, might maintain quantum coherence at body temperature, creating a kind of biological quantum computer within each neuron. While this remains controversial, it opens fascinating possibilities for understanding how consciousness might emerge from quantum mechanical processes. If consciousness is indeed a quantum holographic phenomenon, then your subjective experience might be more than just an emergent property of brain activity. It might be a localized manifestation of the same holographic information processing that underlies physical reality itself. The universe experiencing itself subjectively through billions of conscious observers each one a unique perspective on the cosmic hologram. As you contemplate this possibility, notice how it might change your relationship to your own thoughts and experiences. What if your consciousness is not produced by your brain, but rather received or focused by it? Like a radio tuning into a particular frequency of the cosmic information field. One of the most striking demonstrations of quantum reality's departure from classical expectations is the phenomenon of quantum tunneling, where particles pass through barriers that should be impossible to cross according to classical physics. This isn't science fiction, but a verified quantum effect that occurs billions of times per second in the device you're using to listen to these words. In the classical world, if you roll a ball toward a hill, it will either have enough energy to go over the top, or it won't. There's no middle ground, but in the quantum world, particles can tunnel through energy barriers even when they lack the energy to go over them. They simply appear on the other side, as if the barrier weren't there. This quantum tunneling is essential to the operation of many modern technologies. The scanning tunneling microscope uses electron tunneling to image individual atoms. Computer processors rely on tunneling effects in transistors. Even the fusion reactions that power the sun depend on protons tunneling through the electromagnetic barriers that would otherwise keep them apart. But quantum tunneling might play an even more fundamental role in the emergence of consciousness and life itself. Some researchers propose that quantum tunneling in neural microtubules might be essential to the brain's information processing. Others suggest that tunneling effects in DNA might contribute to genetic mutations and evolution. The implications are profound. If consciousness depends on quantum tunneling effects, then the very thoughts arising in your awareness right now might be examples of the impossible becoming possible, of barriers being crossed that classical physics says cannot be crossed. This connects to something deeper about the nature of possibility itself. In the quantum realm, the impossible is not absolutely forbidden, but only improbable. Given enough time and enough attempts, even the most unlikely quantum events will eventually occur. The universe is not deterministically bound by classical limitations, but is open to genuine novelty and surprise. Consider how this might apply to your own life and experience. What barriers seem impossible to cross from your current perspective? Quantum mechanics suggests that no barrier is absolutely impassable, that the universe is fundamentally open to possibilities that transcend our classical expectations. Among quantum mechanics' strangest revelations is the quantum zeno effect, named after the ancient Greek philosopher who argued that motion is impossible because a moving arrow must occupy a definite position at each instant. In quantum mechanics, this paradox takes on new meaning. Frequent observation can actually freeze a quantum system in its current state, preventing it from evolving. The effect has been demonstrated experimentally. When a quantum system that would normally decay or change state is observed very frequently, the observations prevent the change from occurring. It's as if the act of watching stops time for the quantum system, freezing it in whatever state is being observed. This might sound like pure academic curiosity, but the quantum zeno effect has practical applications in quantum computing and quantum error correction. By making frequent measurements, engineers can prevent quantum information from decaying due to environmental interference, maintaining the delicate quantum states necessary for computation. More intriguingly, some researchers propose that consciousness itself might operate through a kind of quantum zeno effect. If conscious attention involves quantum measurement processes in the brain, then the act of sustained attention might literally freeze certain neural quantum states, creating the stability necessary for coherent thought and experience. This suggests a fascinating possibility about the nature of attention and awareness. When you focus your attention on something, you might not just be passively observing it, but actively stabilizing it through quantum mechanical effects. Your conscious attention might be participating in creating the very stability and continuity of your experience. As you read these words, notice the quality of your attention. The steady focus required to follow this exploration might be more than just a psychological process. It might be a quantum mechanical interaction between your consciousness and the information being processed, with your attention actively participating in creating the coherent experience of understanding. One of the deepest questions in quantum mechanics concerns the relationship between microscopic quantum processes and macroscopic classical phenomena. How does the quantum world give rise to the classical world we experience? And once classical phenomena emerge, can they influence the quantum processes from which they arose? Traditional reductionist thinking suggests that causation flows only upward, from quantum to classical, from small to large, from simple to complex. But quantum mechanics hints at something more subtle. The measurement problem suggests that classical measuring devices somehow cause quantum wave functions to collapse, implying a kind of downward causation from classical to quantum. This opens fascinating possibilities for understanding consciousness and free will. If conscious experience emerges from quantum processes in the brain, and if consciousness can then influence those same quantum processes through something like downward causation, then we might have a quantum mechanical basis for genuine agency and choice. Some interpretations suggest that consciousness might act as a kind of quantum selector, determining which of many possible quantum outcomes become actualized in the classical world. This wouldn't violate any physical laws, but would represent consciousness as an active participant in the quantum to classical transition, rather than just a passive observer of predetermined outcomes. The implications extend beyond individual consciousness to collective and social phenomena. If individual minds can influence quantum processes, and if quantum processes underlie all physical phenomena, then perhaps collective consciousness might have subtle but real effects on the physical world around us. This remains highly speculative, and no scientific consensus exists about consciousness causing quantum effects. But the possibility invites us to consider our role not just as observers of reality, but as participants in its ongoing creation, quantum beings embedded in a quantum universe, where the boundary between mind and matter might be more fluid than we imagine. One of the most surprising discoveries in recent quantum research is that quantum coherence, the delicate superposition of quantum states, can persist in warm, noisy biological systems. This challenges the conventional wisdom that quantum effects require near absolute zero temperatures and perfect isolation from the environment. The discovery began with studies of photosynthesis, but has since expanded to include other biological processes. Quantum coherence has been observed in the light harvesting complexes of plants and bacteria, in the magnetic sensors used by migratory birds, and possibly in the microtubules that form the structural framework of brain cells. This suggests that life itself might have evolved mechanisms to protect and harness quantum coherence, even in the warm, wet, noisy environment of living cells. Rather than being destroyed by biological activity, quantum effects might be essential to how life operates at its most fundamental level. If quantum coherence can persist in biological systems, it opens new possibilities for understanding consciousness itself. Perhaps the unity of conscious experience, the way millions of neural processes integrate into a single, coherent perspective, reflects quantum coherence operating at the scale of the entire brain. Some researchers propose that consciousness might emerge from quantum coherence in networks of microtubules throughout the nervous system, creating a kind of biological quantum computer that processes information in ways that classical computers cannot. While this remains controversial, it suggests that the hard problem of consciousness, how subjective experience arises from objective neural activity, might have a quantum mechanical solution. As you contemplate your own conscious experience right now, consider the possibility that the very unity and coherence of your awareness might reflect quantum mechanical processes operating in the warm, living medium of your brain. The thoughts arising in your consciousness might be quantum phenomena, patterns of coherence emerging from and dissolving back into the quantum field of neural activity. Quantum mechanics reveals a universe that is fundamentally participatory rather than observational. We are not detached observers studying an independent reality, but active participants in an ongoing process of reality creation. Every measurement we make, every observation we conduct, every conscious moment we experience participates in bringing potential into actuality. This participatory vision challenges the classical scientific ideal of objective detachment. The observer cannot be separated from the observed because the act of observation is part of the physical process being studied. Subject and object, mind and matter, observer and observed are not separate entities but different aspects of a single, unified quantum process. Physicist John Wheeler captured this insight in his concept of a participatory universe, where consciousness and cosmos co-create each other in an ongoing dance of observation and manifestation. From this perspective, consciousness is not something that evolved accidentally in a mindless universe, but rather represents the universe's capacity for self-awareness and self-creation. This doesn't mean that consciousness creates reality in some magical sense, but rather that consciousness and reality are co-emergent aspects of a deeper quantum process that transcends the classical distinction between subjective and objective, between mental and physical, between observer and observed. The implications are profound for how we understand our place in the cosmic order. We are not accidents in a meaningless universe, but rather expressions of the universe's intrinsic capacity for consciousness and creativity. Every moment of awareness, every act of observation, every conscious choice participates in the ongoing evolution of reality itself. If you find yourself captivated by these explorations of consciousness and quantum reality, our community members get to experience these journeys completely ad-free, with early access to each episode 48 hours before public release. It's a way to support this work while diving even deeper into the mysteries we explore together. You can join whenever you feel ready, but for now, let's continue our journey into the participatory nature of quantum reality. One of the most remarkable features of quantum mechanics is its capacity for genuine novelty. Unlike classical deterministic systems, where the future is entirely determined by the past, quantum systems contain an element of fundamental randomness that allows for truly new possibilities to emerge. This quantum creativity operates at every level of reality. In the quantum vacuum, virtual particles spontaneously appear and disappear, contributing to the zero-point energy that pervades all of space. In atomic nuclei, quantum tunneling allows for radioactive decay at unpredictable moments. In biological systems, quantum effects might contribute to genetic mutations that drive evolutionary change. But perhaps most intriguingly, a number of scientists and philosophers have wondered whether quantum indeterminacy might relate to creativity or free will, though these ideas remain exploratory rather than established. If conscious thought involves quantum processes, then the emergence of new ideas, insights, and creative inspirations might reflect the fundamental creativity of the quantum realm expressing itself through neural networks. Some researchers propose that the randomness inherent in quantum mechanics provides the physical basis for free will, allowing conscious beings to make genuine choices rather than simply following deterministic programs. While this remains speculative, it suggests that human creativity and agency might be expressions of the universe's own creative potential. This quantum creativity is not chaotic randomness, but follows statistical patterns that allow for both novelty and order. The quantum world is neither completely determined nor completely random, but occupies a middle ground where new possibilities can emerge within lawful constraints. Consider how this might illuminate your own creative process. When new ideas arise seemingly from nowhere, when sudden insights solve long-standing problems, when unexpected connections form between previously separate concepts, you might be experiencing quantum creativity at work in your own neural networks. As we near the end of our exploration, we return to the fundamental mystery that has guided our journey: the role of measurement and observation in quantum mechanics. But now we can see this mystery in a new light, not just as a technical problem in physics, but as a window into the deepest questions about meaning, purpose, and the nature of existence itself. In quantum mechanics, measurement is not just the detection of pre-existing properties, but an active process that brings properties into being. The act of measurement creates the very thing being measured. This suggests a universe where meaning is not discovered but created, where purpose emerges from the interaction between consciousness and cosmos. This measurement-creation relationship might extend far beyond physics laboratories. Every act of attention, every moment of conscious awareness, every choice to focus on one possibility rather than another might be a kind of measurement that brings certain aspects of reality into sharper focus, while allowing others to remain in quantum superposition. From this perspective, the meaning of your life is not something predetermined that you must discover, but something you actively create through the choices you make, the attention you give, the observations you conduct. You are not just finding your purpose, but literally measuring it into existence through the conscious decisions that shape your experience. This doesn't mean that meaning is arbitrary or purely subjective. Just as quantum measurements must respect the mathematical constraints of quantum mechanics, the meaning you create must resonate with the deeper patterns and possibilities inherent in the quantum structure of reality itself. Our journey through quantum reality brings us finally to a recognition that transforms everything: the eternal nature of the present moment. If time is indeed emergent from our timeless quantum correlations, if past and future exist simultaneously in a higher dimensional quantum state, then the present moment is not just a fleeting instant between what was and what will be, but the eternal ground from which all temporal experience arises. This eternal present is not static or fixed, but dynamically alive with infinite potential. It contains all possibilities, all histories, all futures, held in quantum superposition until consciousness observes specific aspects into classical manifestation. The present moment is the interface between timeless quantum potential and temporal classical actuality. In this eternal present, every moment of your experience has the same ontological status as every other moment. The memories you carry of the past and the anticipations you hold of the future are both arising now in this eternal present as different aspects of your current quantum state of consciousness. This perspective can be profoundly liberating. If the past exists only as present memory patterns and the future only as present potential, then you are free in each moment to choose which aspects of the quantum field of possibilities you will observe into actuality. The story of your life is not fixed in stone, but is being written moment by moment through your conscious choices and observations. As you breathe in and out, feeling the air enter and leave your body, you are experiencing the eternal present directly. This breath, this heartbeat, this moment of awareness is not separate from the fundamental quantum processes that underlie all of reality. You are the universe experiencing itself in this eternal now, consciousness arising from and returning to the timeless quantum ground of all being. As our exploration draws toward its close, we find ourselves standing before a kind of quantum mirror, seeing our own nature reflected in the strange properties of quantum reality. Every mystery we've encountered in quantum mechanics mirrors a mystery in consciousness and existence itself. The observer effect reflects the profound mystery of how consciousness emerges from physical processes while simultaneously influencing those same processes. Quantum superposition mirrors the way consciousness can hold multiple possibilities simultaneously before choosing which to actualize through attention and intention. Quantum entanglement reflects the deep interconnectedness we sometimes sense with others and with the universe as a whole. The measurement problem in quantum mechanics parallels the hard problem of consciousness. How does subjective experience arise from objective processes? The quantum field view of reality mirrors contemplative insights about the illusory nature of separate selfhood and the underlying unity of all existence. This is not to say that quantum mechanics proves ancient wisdom or that consciousness literally causes quantum effects. Rather, it suggests that the same deep patterns that govern quantum reality also govern the emergence and operation of consciousness. We are quantum phenomena, contemplating quantum phenomena, aspects of the universe investigating itself. This quantum mirror reveals that the strangeness we've discovered in the physical world is not separate from us, but is our own deepest nature. We are not classical beings living in a quantum universe, but quantum beings who have learned to think classically about ourselves and our world. The journey of understanding quantum mechanics is therefore also a journey of self-discovery, revealing not just how reality works, but what we are as conscious observers embedded in that reality. Every quantum mystery illuminates a corresponding mystery in the nature of consciousness, awareness, and existence itself. Our exploration of quantum reality returns us to something we knew as children, but forgot as we learned to think classically about the world. A sense of fundamental wonder at the mystery of existence. Quantum mechanics reveals that wonder is not a childish emotion to be outgrown, but an appropriate response to the genuine mystery of reality. The classical worldview promised to eliminate mystery through complete knowledge and control. Every phenomenon would eventually be explained, every force harnessed, every question answered. But quantum mechanics shows us that mystery is not a temporary ignorance to be overcome, but a fundamental feature of reality itself. This is not the mystery of superstition or ignorance, but the mystery of genuine depth, the recognition that reality extends far beyond our current understanding and perhaps beyond any possible understanding. It's the mystery that arises when finite minds encounter the infinite, when classical concepts meet quantum reality, when consciousness investigates its own nature. This quantum wonder is not passive amazement but active engagement with mystery. It invites us to participate in the ongoing exploration of reality while remaining humble about the limits of our knowledge. It encourages us to embrace uncertainty as a creative force, rather than something to be eliminated. Living with quantum wonder means holding our beliefs lightly, remaining open to possibilities that transcend our current understanding, and approaching both science and life with what Zen Buddhism calls beginner's mind. The openness and curiosity of someone encountering reality for the first time. As you continue your own exploration of these mysteries, remember that wonder is not just a feeling, but a way of being in the world, a recognition that existence itself is far more strange and magnificent than our concepts can capture. As we prepare to conclude this journey, it's worth considering where our understanding of quantum reality might lead us. We stand at a unique moment in human history, where our scientific understanding of the quantum nature of reality is converging with technological capabilities that can harness quantum effects and contemplative insights that recognize the participatory nature of consciousness. This convergence suggests possibilities that would have seemed like magic to previous generations. Quantum computers that can solve problems impossible for classical systems. Quantum communication networks that provide perfect security through the laws of physics themselves. Quantum sensors that can detect the faintest traces of gravitational waves or magnetic fields. But perhaps more importantly, our growing understanding of quantum reality is changing how we understand ourselves and our place in the universe. We're learning to see consciousness not as something separate from the physical world, but as an integral aspect of the quantum processes that underlie all of reality. This integration of quantum physics and consciousness research might lead to new understandings of mental health, creativity, and human potential. If consciousness operates through quantum processes, then practices that influence consciousness, meditation, contemplation, creative expression, might have subtle but real effects on the quantum foundations of our being. The future might hold technologies that interface directly with the quantum processes underlying consciousness, expanding our capabilities in ways we can barely imagine. But more than any external technology, the deepest transformation might come from recognizing our own quantum nature and learning to live in harmony with the fundamental principles that govern both quantum reality and conscious experience. What does it mean to live consciously as a quantum being in a quantum universe? How do we integrate the insights of quantum mechanics into our daily experience? These questions don't have simple answers, but they point toward a way of being that honors both scientific understanding and lived experience. Living quantum consciousness means embracing uncertainty as a fundamental feature of reality rather than something to be eliminated. It means recognizing that the future is genuinely open, shaped by both quantum randomness and conscious choice. It means holding our beliefs and expectations lightly, remaining open to possibilities that transcend our current understanding. It means recognizing our deep interconnection with all of reality, not as a philosophical ideal, but as a physical fact revealed by quantum entanglement and the field structure of quantum reality. The boundaries between self and world, between observer and observed, are revealed to be conceptual conveniences rather than absolute divisions. Living quantum consciousness means appreciating the participatory nature of reality, recognizing that we are not separate observers studying an independent world, but active participants in an ongoing process of reality creation. Every choice we make, every observation we conduct, every moment of conscious awareness participates in bringing possibility into actuality. It means approaching life with what we might call quantum humility, recognizing that our classical concepts and categories are limited tools for understanding a reality that is far more subtle, interconnected, and mysterious than our everyday thinking suggests. Most importantly, living quantum consciousness means remaining open to wonder, maintaining childlike curiosity about the mystery of existence while engaging seriously with both scientific understanding and contemplative inquiry into the nature of consciousness and reality. As our exploration reaches its conclusion, we recognize that every ending is also a beginning. The insights we've gained into the quantum nature of reality open up new questions, new possibilities, new avenues for exploration and understanding. The measurement problem in quantum mechanics remains as mysterious as ever, perhaps more so now that we've seen its implications ripple through every aspect of existence. Each attempt to solve it seems to reveal new layers of mystery, new questions about the nature of reality, consciousness, and observation itself. We've journeyed from the simple double-slit experiment to the holographic universe, from quantum computers to quantum biology, from the timeless nature of quantum reality to the participatory role of consciousness. Along the way, we've discovered that reality is far stranger, more interconnected, and more wonderful than our classical concepts could ever capture. But perhaps the most profound discovery is that we are not separate from the reality we're investigating. We are quantum phenomena studying quantum phenomena, consciousness arising from the very processes we're trying to understand. The observer and the observed are not separate entities, but different aspects of a single, unified quantum process. This recognition transforms our relationship to existence itself. We are not accidents in a meaningless universe, but expressions of the universe's capacity for self-awareness and self-understanding. Every moment of consciousness, every act of observation, every conscious choice participates in the ongoing evolution of reality itself. If we listen carefully to the implications of quantum mechanics, we begin to hear something like a cosmic symphony, a vast orchestration of possibilities and actualities, waves and particles, observers and observed, all dancing together in patterns too complex for any single mind to grasp completely. In this symphony, consciousness plays not just one instrument, but serves as both musician and audience, both composer and composition. We are the universe making music with itself, creating melodies of meaning and harmony from the fundamental rhythms of quantum mechanics. The various interpretations of quantum mechanics, Copenhagen, many worlds, pilot wave theories, objective collapse models, are like different ways of notating this cosmic symphony. Each captures certain aspects of the music while missing others. Perhaps no single notation system can capture the full richness of the quantum composition that underlies all existence. This doesn't mean that all interpretations are equally valid or that science is merely subjective. The experimental tests of quantum mechanics provide objective constraints on any valid interpretation, but within those constraints, there may be room for multiple perspectives, each illuminating different aspects of the deeper reality that transcends all our conceptual frameworks. As you reflect on this quantum symphony, notice how it might be playing in your own experience right now. The coherent flow of thoughts and sensations, the way attention moves from one aspect of experience to another, the mysterious emergence of consciousness itself from neural processes, all might be expressions of this deeper quantum orchestration. One of the most remarkable aspects of quantum mechanics is how its principles seem to echo in our direct experience, even though quantum effects are typically considered to be confined to microscopic scales. While we must be careful not to overextend quantum concepts into domains where they don't apply, we can explore the parallels thoughtfully. Consider the observer effect in your own life. How often have you noticed that the act of paying attention to something changes it? When you observe your own thoughts carefully, they seem to shift. When you focus on a problem with sustained attention, new solutions often emerge. When you truly listen to another person, the quality of the conversation transforms. This isn't quantum mechanics in any literal sense, but it suggests that the principle of participatory observation might operate at multiple levels of reality. Some interpretations suggest that the same fundamental patterns that govern quantum mechanics might manifest in different forms at different scales of organization. The uncertainty principle, too, finds echoes in lived experience. There seem to be complementary aspects of life that cannot be grasped simultaneously. You cannot simultaneously experience complete security and complete freedom, perfect knowledge and genuine wonder, absolute control and authentic surrender. Like quantum complementarity, these pairs seem to exclude each other in direct experience, while both being necessary for a complete understanding. Quantum entanglement might reflect something about the interconnectedness we sometimes sense with others, with nature, with the universe as a whole. While there's no scientific evidence that human beings can become quantum entangled in any meaningful sense, the principle of entanglement reveals that reality is far more interconnected than our classical concepts suggest. Take a moment to notice any sense of connection you might feel right now, with the words you're hearing, with the space around you, with the larger world beyond your immediate experience. This feeling of connection, while not quantum entanglement in any technical sense, might reflect your participation in the deeply interconnected fabric of quantum reality. Perhaps one of the most valuable gifts quantum mechanics offers is an expansion of imagination. It shows us that reality is far more creative, more flexible, more open to possibility than we ever suspected. This expanded imagination can transform how we approach not just science, but life itself. The quantum principle of superposition suggests that reality holds multiple possibilities simultaneously until something causes a specific outcome to manifest. While this doesn't mean we can control reality through thought, it does suggest that the future is genuinely open, full of potential that hasn't yet crystallized into definite form. This openness to possibility can be profoundly liberating. Instead of seeing yourself as trapped by past conditioning or future obligations, you might recognize that each moment contains genuine choices, real opportunities for growth and change. The story of your life is not predetermined, but is being written moment by moment through your conscious engagement with the quantum field of possibilities. The quantum concept of tunneling shows us that barriers that seem absolute in classical thinking might be permeable to quantum possibilities. While you can't literally tunnel through walls, the principle suggests that obstacles that seem insurmountable might have unexpected solutions, that apparent limitations might be less absolute than they appear. Quantum creativity, the capacity for genuine novelty to emerge from quantum processes, reminds us that innovation and insight are not just rearrangements of existing elements, but can represent truly new possibilities arising from the fundamental creativity of reality itself. As you contemplate your own creative potential, consider how it might connect to this deeper quantum creativity, when new ideas arise seemingly from nowhere, when unexpected solutions present themselves. When you surprise yourself with insights you didn't know you had, you might be experiencing the fundamental creativity of the universe expressing itself through your consciousness. Recent developments in quantum biology suggest that living systems have evolved remarkable abilities to maintain and exploit quantum effects in warm, noisy environments. This discovery transforms our understanding of the relationship between quantum mechanics and life, consciousness, and mind. If quantum coherence can persist in biological systems, it opens fascinating possibilities for understanding consciousness itself. Some interpretations suggest that the unity and coherence of conscious experience might reflect quantum mechanical processes operating in the warm, living medium of the nervous system. While this remains highly speculative, it invites us to consider consciousness not as something separate from the physical world, but as an integral expression of the same quantum principles that govern all of reality. The mind emerges from and remains embedded in the quantum ecology of the body and environment. This ecological view of mind suggests that consciousness is not contained within the boundaries of the individual brain, but extends into the quantum fields that connect all things. While we must be careful not to overstate this connection, the field structure of quantum reality suggests that the boundaries we draw around individual minds might be more conceptual than physical. From this perspective, thinking and feeling are not private internal processes, but participations in larger patterns of information and energy flow that extend throughout the quantum fabric of reality. Your thoughts and emotions arise from and contribute to the ongoing dance of quantum fields that underlies all existence. This doesn't mean that individual privacy and autonomy are illusions, but rather that they exist within a larger context of interconnection and mutual influence that operates at levels too subtle for ordinary awareness to detect. What might it mean to live artfully in light of quantum insights? How can we integrate the discoveries of quantum mechanics into a way of being that honors both scientific understanding and the full richness of human experience? Living quantum consciousness might begin with cultivating what we could call quantum sensitivity, an awareness of the subtle, interconnected, probabilistic nature of reality. This means paying attention to the spaces between things, the potential that exists before it crystallizes into actuality, the ways that observation and intention participate in shaping experience. It might involve developing comfort with uncertainty and ambiguity, recognizing that these are not problems to be solved but fundamental features of reality to be embraced. Instead of always seeking definitive answers, we might learn to dance with questions, to find wisdom in not knowing, to discover the creative potential that exists in the space between possibilities. Quantum living might also involve practicing what we could call participatory awareness, recognizing that we are not separate observers of reality, but active participants in its ongoing creation. This doesn't mean we control reality through our thoughts, but rather that our choices, attention, and actions contribute to the unfolding patterns of existence in ways both subtle and profound. It might include cultivating appreciation for complementarity, the recognition that some aspects of reality can only be understood from multiple, seemingly contradictory perspectives. Instead of insisting on single, consistent viewpoints, we might learn to hold paradox gracefully, to see truth as multifaceted rather than monolithic. Take a breath and notice how these principles might already be operating in your experience. The way you navigate uncertainty in daily life, the moments when you sense deeper connections, the times when your attention seems to shift the quality of your experience, all might be expressions of quantum principles manifesting at the scale of human consciousness. As we prepare to bring our exploration to a close, we might ask what quantum mechanics reveals about the deepest aspects of human experience: love, compassion, meaning, and purpose. While these qualities emerge from the complexity of human consciousness, rather than from quantum effects directly, they exist within and express the same fundamental principles that govern quantum reality. Love might be understood as a recognition of the deep interconnectedness that quantum mechanics reveals at the foundation of reality. When we feel profound connection with another being, we might be sensing something true about the non-local, entangled nature of existence itself. While human love is not quantum entanglement in any technical sense, it might reflect our intuitive recognition of the fundamental unity that underlies apparent separation. Compassion could be seen as an expression of the participatory nature of quantum reality. When we recognize that the suffering and joy of others is not separate from our own experience, we might be responding to the deeper truth that observer and observed, self and other, are not independent entities but aspects of a unified quantum process. Meaning and purpose might emerge from our participation in the ongoing creativity of the quantum universe. Instead of seeking predetermined purposes written into the fabric of reality, we might find meaning in our active participation in the universe's process of self-discovery and self-creation. This doesn't reduce these profound human experiences to mere physics, but rather suggests that physics and human experience are both expressions of deeper principles that govern the evolution of consciousness and cosmos together. Every journey eventually leads us home, but we return transformed by what we've seen and understood. Our exploration of quantum reality brings us back to the immediate present, to this moment of consciousness in which you're receiving these words, but we return with expanded awareness of what this moment contains. This present moment, which seemed so simple and straightforward when we began, now reveals itself to be a nexus of quantum possibilities, a point where timeless potential crystallizes into temporal experience, where consciousness and cosmos meet in the eternal dance of observation and manifestation. The thoughts arising in your awareness, the sensations flowing through your body, the sense of being a conscious observer embedded in a vast universe, all are revealed to be expressions of the same quantum principles that govern the behavior of electrons and photons in physics laboratories. You are not separate from the reality you've been learning about, but are its intimate expression, quantum consciousness arising from quantum processes, the universe experiencing itself subjectively through the unique perspective of your individual awareness. This recognition doesn't diminish your individuality or reduce you to mere physics, but rather reveals the profound dignity of consciousness as the means by which the universe comes to know itself. You are both utterly unique and fundamentally connected, a singular perspective on the infinite mystery of existence. As our journey draws to its close, we recognize that ending and beginning are themselves classical concepts that don't quite capture the quantum nature of reality. In the timeless realm of quantum potential, every conclusion opens new possibilities. Every answer generates new questions. Every arrival is also a departure. The insights we've gained into the quantum nature of reality are not final destinations, but invitations to ongoing exploration and discovery. Each principle we've explored, superposition, entanglement, the observer effect, complementarity, opens doorways into deeper mysteries that extend far beyond the boundaries of current scientific understanding. The measurement problem in quantum mechanics, which we've encountered repeatedly throughout our journey, remains as profound a mystery as ever. But now we can see it not as a problem to be solved once and for all, but as a creative tension that drives the ongoing evolution of both scientific understanding and conscious awareness. We are participants in this evolution, not just as scientists and philosophers, but as conscious beings whose very existence represents the universe's capacity for self-awareness and self-understanding. Every moment of conscious attention, every act of observation, every choice to engage with mystery rather than retreat into certainty, contributes to the cosmic process of discovery and creation. The dance between consciousness and cosmos, between observer and observed, between potential and actual, continues in each moment of your experience. You are not just learning about quantum mechanics, you are quantum mechanics in action, the universe investigating its own deepest nature through the unique lens of your awareness. And so we arrive, gently, at the end of this particular exploration, though the deeper journey continues with every breath, every heartbeat, every moment of conscious awareness. The quantum universe we've discovered together is not a distant realm, accessible only through complex mathematics and elaborate experiments, but the intimate reality of your direct experience, here and now. The strange behaviours we've explored, particles existing in multiple states simultaneously, reality emerging from the act of observation, distant correlations that transcend space and time, are not aberrations to be explained away, but revelations of the fundamental creativity and mystery that underlies all existence. You are both the observer and the observed, the questioner and the question, the seeker and the sought. In your consciousness, the universe experiences itself subjectively, and through your choices and actions, consciousness participates in the ongoing creation of reality. The journey we've shared reveals that wonder is not a childish emotion to be outgrown, but the appropriate response to existence itself. In a quantum universe where reality emerges from observation, where possibility and actuality dance together in eternal creativity, where consciousness and cosmos co-create each other moment by moment, wonder is both the starting point and the destination of all genuine inquiry. As you continue your own exploration of these mysteries, remember that you carry within your very being the same quantum principles that govern the behaviour of particles in laboratory experiments. You are not separate from the universe you inhabit, but are its intimate expression, quantum consciousness arising from and contributing to the magnificent mystery of existence itself. The next time you gaze up at the stars, remember that you are looking at your own deepest nature, reflected in the cosmic mirror. The quantum fields that give rise to those distant suns are the same fields that give rise to your thoughts, your dreams, your capacity for wonder and understanding. In recognizing the quantum nature of reality, we haven't solved the mystery of existence. we've deepened it in the most beautiful way possible. We've discovered that we are not accidents in a meaningless universe, but expressions of the universe's intrinsic capacity for consciousness, creativity, and love. Rest now in this recognition, breathing gently with the quantum rhythms that pulse through every atom of your being, every cell of your body, every thought in your mind. You are quantum consciousness exploring its own infinite nature, and that exploration will continue as long as awareness itself endures. If you found yourself drawn deeper into these mysteries of quantum reality and consciousness, you might enjoy exploring what happens when we fully embrace the implications of quantum uncertainty in Something Strange Happens. When you trust quantum mechanics, where we discover how accepting the fundamental uncertainty of reality might paradoxically lead us to a more profound sense of meaning and connection than any classical certainty ever could. Thank you for joining me on this journey into the heart of quantum reality. May your continued exploration be filled with wonder, wisdom, and the deep peace that comes from recognizing your intimate connection to the magnificent mystery of existence itself. What remains perhaps most remarkable about our quantum journey is how it returns us, inevitably, to the question of measurement itself. Not just the technical measurement that physicists conduct in laboratories, but the deeper kind of measurement that consciousness performs simply by being aware. Every moment of your experience right now involves a kind of cosmic measurement where the infinite potential of quantum reality collapses into the specific experience of being you, here now. Consider this carefully. The very fact that you can distinguish between the sound of these words and the silence that surrounds them represents a form of measurement. Your consciousness is somehow selecting, from all possible auditory experiences, this particular pattern of meaning. The warmth you might feel in your chest, the weight of your body against whatever surface supports you, the quality of light that reaches your eyes, all emerge from quantum processes that remain fundamentally mysterious. Scientists can describe the mathematics of how quantum states collapse into classical measurements, but the deeper question persists. What is it about consciousness that seems to participate in this collapse? Some interpretations speculate that awareness could play a role in how quantum possibilities become classical outcomes, a hypothesis still under debate. This isn't to claim that your thoughts control quantum events, for which there remains no scientific evidence. Rather, it's to recognize that consciousness and quantum measurement might be different aspects of the same fundamental process by which potential becomes actual, possibility becomes experience, and the timeless quantum realm gives birth to the flowing world of time and change. As you rest in this moment, breathing naturally, you might sense something of this measureless measurement taking place. The arising and passing of thoughts, the subtle shifts in sensation and perception, the continuous emergence of experience from some deeper source that remains forever beyond direct observation, yet intimately present in every moment of awareness. Our exploration has led us to a profound paradox that lies at the heart of both quantum mechanics and consciousness itself. The more precisely we try to pin down the nature of reality, the more it seems to slip away into uncertainty and mystery. This isn't a failure of our instruments or understanding, but appears to be built into the very structure of existence. Heisenberg's uncertainty principle tells us that we cannot simultaneously know both the position and momentum of a particle with perfect precision, but this limitation extends far beyond particles into the realm of knowledge itself. The act of knowing something completely seems to require a kind of stillness, a freezing of the dynamic process that gives rise to what we're trying to understand. Think about your own experience of trying to capture a beautiful moment. The sunset that takes your breath away, the perfect note in a piece of music, the feeling of deep connection with another person. The moment you try to grasp it completely, to analyze it or preserve it, something essential seems to escape. The very act of trying to possess the experience changes it into something else. This isn't mere sentimentality, but might reflect something fundamental about the relationship between consciousness and reality. Some interpretations suggest that consciousness and the reality it observes exist in a state of dynamic tension, each one shaping the other in ways that prevent either from being completely captured or understood from the outside. The quantum world teaches us that perfect knowledge might be not just practically impossible, but theoretically meaningless. Instead of seeking to eliminate mystery through complete understanding, we might learn to dance with uncertainty, to find wisdom in not knowing, to discover the creative potential that exists in the space between question and answer. This doesn't mean abandoning the pursuit of knowledge, but rather approaching it with what contemplatives have long called beginner's mind. Each moment of genuine inquiry, whether scientific or personal, requires a willingness to let go of what we think we know and remain open to what wants to emerge. Recent discoveries in quantum biology suggest that the boundary between quantum and classical reality runs right through the middle of your living body. The cells that make up your tissues, the proteins that catalyze your biochemistry, even the neural networks that give rise to your thoughts, all operate through processes that depend fundamentally on quantum mechanical effects. Some emerging research suggests that quantum tunneling may contribute to certain biological processes, but this remains an active scientific question. The energy that powers your heartbeat comes from quantum processes in the mitochondria of your cardiac muscle cells. Even the thoughts arising in your consciousness emerge from quantum events in the ion channels and synapses of your nervous system. This isn't mystical speculation, but represents the cutting edge of biological research. Scientists have discovered quantum coherence effects in photosynthesis, quantum entanglement in avian navigation systems, and quantum tunneling in the enzymes that regulate cellular metabolism. Life, it seems, has learned to harness quantum effects in ways that our technology is only beginning to approach. What makes this particularly remarkable is that these quantum effects persist in the warm, wet, noisy environment of living cells, where conventional wisdom suggests they should be destroyed almost instantly by decoherence. Somehow, biological systems have evolved mechanisms to protect and exploit quantum coherence under conditions that physicists would consider impossible for maintaining quantum effects. Take a moment to sense your body from the inside, the gentle rhythm of your breathing, the steady pulse of your heart, the subtle sensations that flow continuously through your tissues. All of this emerges from quantum processes operating at scales so small and so fast that they remain completely below the threshold of ordinary awareness. You are not just a classical object that happens to be made of quantum particles. You are a quantum phenomenon that has learned to create and maintain classical stability, a dynamic pattern of information and energy that emerges from and returns to the quantum field that underlies all existence. Some interpretations suggest that consciousness itself might be a kind of quantum phenomenon, arising from coherent quantum processes in the microtubules that form the structural framework of brain cells. While this remains highly speculative, it opens fascinating possibilities for understanding how subjective experience emerges from objective neural activity. Among all the mysteries quantum mechanics reveals, perhaps none is more profound than its relationship to time itself. In the deepest mathematical descriptions of quantum reality, time doesn't flow from past through present to future. Instead, all moments exist simultaneously in what physicists call the block universe, a four-dimensional structure where past and future are equally real and present. This timeless perspective helps resolve some of the strangest aspects of quantum mechanics. The delayed choice experiments we explored earlier become less paradoxical when we recognize that there is no absolute before and after at the quantum level. The measurement that seems to reach backward in time to influence a particle's past behavior is actually part of a single, timeless quantum event that includes both the particle's journey and the eventual measurement. Consider what this might mean for your experience of memory and anticipation. The past you remember and the future you imagine might not be separate from the present moment, but different aspects of a single, timeless quantum state. Your sense of moving through time might be more like consciousness moving its focus through different regions of an eternal multi-dimensional landscape. This doesn't negate the reality of change or the importance of sequence in the world of experience, but it suggests that the flowing river of time might be more like a still lake that consciousness traverses, creating the illusion of current and direction through the movement of attention itself. Some contemplatives have long reported experiences of stepping outside the normal flow of time, moments when past, present, and future seem to collapse into an eternal now that contains all possibilities. While these experiences can't be verified scientifically, they might reflect genuine contact with the timeless quantum substrate that underlies temporal experience. As you breathe in and out, notice the curious relationship between the timeless awareness that observes and the flowing experience that is observed. The thoughts that arise and pass away, the sensations that shift and change, the emotions that ebb and flow, all occur within a field of awareness that itself seems to exist outside the stream of time. One of the most striking features of quantum mechanics is how it reveals a universe that seems almost generously creative in its fundamental nature. Unlike the mechanistic cosmos of classical physics, where everything unfolds according to predetermined laws, the quantum universe contains genuine novelty, authentic creativity, and endless possibility. The quantum vacuum, what we once thought of as empty space, turns out to be a bubbling sea of virtual particles appearing and disappearing in spontaneous acts of creation and annihilation. These aren't just mathematical artifacts, but have measurable effects on the world around us, contributing to forces like the Casimir effect and influencing the behaviour of atoms and molecules. This quantum creativity operates at every level of reality. Radioactive decay occurs through spontaneous quantum tunneling events that cannot be predicted in advance. Genetic mutations that drive evolutionary change might depend on quantum effects in DNA replication. Even the thoughts arising in your consciousness might reflect the fundamental creativity of quantum processes in neural networks. But perhaps most remarkably, this creativity isn't random chaos but follows deep patterns and symmetries that allow for both novelty and order. The quantum world is neither completely determined nor completely chaotic, but occupies a middle ground, where genuine surprise is possible within lawful constraints. This suggests a universe that is fundamentally generous, not in any anthropomorphic sense, but in its basic structure. Reality seems designed to support rather than oppose the emergence of complexity, consciousness, and creativity. The same quantum principles that make atomic stability possible also make life, awareness, and the capacity for wonder possible. Some interpretations suggest that consciousness itself might be an expression of the universe's fundamental creativity, the way reality becomes aware of its own creative potential. From this perspective, your capacity for insight, imagination, and artistic expression might be local manifestations of the cosmic creativity that operates at the quantum level throughout the universe. Take a breath and consider the remarkable creativity that brought you into existence. The quantum processes that forged the atoms in your body within ancient stars. The evolutionary creativity that led to consciousness. The neural creativity that gives rise to your thoughts and dreams. All reflect the same fundamental generosity that characterizes quantum reality at its deepest level. As our understanding of quantum mechanics deepens, we begin to see consciousness not as something separate from the physical world, but as an integral part of what physicists call the quantum information structure of reality. Information, it seems, might be more fundamental than matter and energy, with both mind and matter emerging from deeper patterns of information processing. This information-theoretic view of reality helps make sense of many quantum mysteries. The observer effect becomes the universe processing information about its own states. Quantum entanglement becomes the sharing of information across space and time. The measurement problem becomes a question about how information gets integrated and decoded into conscious experience. Your awareness right now might be understood as a localized intensification of the information processing that occurs throughout the quantum field structure of reality. The thoughts arising in your mind, the sensations flowing through your body, the sense of being a unified self, all emerge from the same informational patterns that give rise to particles, forces, and the structure of space-time itself. This doesn't reduce consciousness to mere computation, any more than quantum mechanics reduces reality to mathematics. Rather, it suggests that mind and matter are different aspects of something more fundamental that transcends our usual categories of subjective and objective, mental and physical. Some researchers have proposed hypotheses suggesting that consciousness may be woven into the structure of reality in ways we don't yet understand. Ideas that remain speculative but fascinating. If consciousness is indeed fundamental rather than emergent, then your awareness is not produced by your brain, but rather focused or organized by it. Like a radio tuning into a particular frequency of the cosmic information field. This would mean that consciousness extends far beyond the boundaries of individual brains and bodies, connecting us all within a larger field of awareness. This isn't meant as a literal scientific claim, for which no evidence currently exists, but as a way of thinking about consciousness that honors both its intimate personal nature and its potential connection to something larger than individual experience. Throughout our journey, we've encountered the limits of knowledge again and again. The measurement problem remains unsolved. Multiple interpretations of quantum mechanics make identical predictions while proposing radically different pictures of reality. The relationship between consciousness and quantum mechanics remains deeply mysterious. These limitations aren't failures of scientific method, but might reflect something fundamental about the nature of reality itself. Some aspects of existence might be inherently unknowable, not because of the limitations of our instruments or concepts, but because knowing and being exist in a dynamic tension that prevents either from being completely captured by the other. This recognition invites us to cultivate what we might call the art of not knowing, a way of engaging with mystery that doesn't seek to eliminate it through complete understanding, but learns to find wisdom and beauty in uncertainty itself. This isn't ignorance or intellectual laziness, but a sophisticated form of knowing that includes its own limits. The quantum world teaches us that precision in one aspect of knowledge necessarily creates uncertainty in complementary aspects. This principle of complementarity might extend beyond physics into all forms of understanding. Perhaps we cannot simultaneously grasp the full depth and breadth of any phenomenon, the complete mechanism and the ultimate meaning, the perfect explanation and the living mystery. In your own experience, you might have noticed that the most profound moments often resist analysis. The beauty of a sunset, the feeling of deep love, the sense of connection with something larger than yourself, all seem to exist in a realm that transcends conceptual understanding while being intimately present in direct experience. This doesn't mean abandoning the pursuit of knowledge, but rather holding it more lightly, approaching each question with genuine curiosity, while remaining open to the possibility that the answer might be larger, stranger, or more beautiful than we initially imagined. The art of not knowing involves learning to rest comfortably in uncertainty, to find peace in the space between question and answer, to discover the creative potential that exists when we don't already know what we're going to find. As we approach the completion of our exploration, we find ourselves returning to the light that started our journey, but now we see it with new eyes. The photons streaming from your screen or the sunlight filtering through your window are no longer just classical electromagnetic radiation, but quantum phenomena, carrying information across space and time in ways that transcend our ordinary understanding. Each photon represents a quantum of possibility that becomes actualized through the process of observation. When light from a distant star reaches your eye tonight, you'll be completing a quantum measurement that began years ago when the photon was emitted. The light carries not just energy, but information, connecting you across vast distances to the nuclear furnaces where it was born. This light that makes vision possible, that powers photosynthesis and drives the weather patterns of Earth, that carries the cosmic microwave background radiation from the early universe, all operates according to the same quantum principles. We've explored wave and particle, potential and actual, observer and observed, all dancing together in the eternal play of light and consciousness. Your ability to see these words, to process their meaning, to have thoughts and experiences in response to them, depends on quantum processes occurring millions of times per second in the photoreceptors of your eyes and the neural networks of your brain. You are literally a light processing system, consciousness arising from the interaction between quantum electromagnetic fields and the quantum field phenomena that constitute your nervous system. Some interpretations suggest that consciousness itself might be understood as a kind of inner light, not in any mystical sense, but as the subjective aspect of the information processing that occurs when quantum fields interact in the complex patterns that give rise to awareness. The light of consciousness that illuminates your experience might be intimately related to the electromagnetic processes that make neural computation possible. Take a moment to appreciate the light that makes this moment possible. Whether artificial or natural, this illumination connects you to quantum processes occurring throughout the universe, from the fusion reactions in stellar cores to the quantum tunneling events in the LED chips or incandescent filaments that may be providing your current lighting. Our exploration brings us finally to a recognition that transforms everything we thought we knew about time, existence, and our place in the cosmic order. If the deepest levels of reality are indeed timeless, if past and future exist simultaneously in the quantum block universe, then the present moment is not a fleeting instant between what was and what will be, but the eternal ground from which all temporal experience emerges. This eternal present is not static or empty, but dynamically alive with infinite potential. It contains all possibilities, all histories, all futures, held in quantum superposition until consciousness selects specific aspects to observe into classical manifestation. You are not moving through time, but rather time is flowing through you, with each moment of awareness representing a cross-section through the eternal quantum state of all that is. In this view, every moment of your life has equal ontological status. The childhood memory that feels distant, the future hope that seems uncertain, the immediate sensation of breathing, all exist now in the timeless quantum substrate of reality. The story of your life is not a linear sequence of events, but a multi-dimensional pattern in the eternal present, accessible through different modes of consciousness and attention. This perspective can be profoundly liberating. If the past exists only as present memory patterns and the future only as present potential, then you are free in each moment to choose which aspects of the quantum field of possibilities you will observe into actuality. The conditioning that seems to limit you, the circumstances that appear to constrain you, exist only in the timeless present, where they can be met with fresh awareness and creative response. This doesn't mean that consequences don't matter, or that you can change the past through wishful thinking. Rather, it suggests that your relationship to past and future can be transformed through deeper understanding of their present moment reality. What seemed fixed and unchangeable might reveal unexpected flexibility when approached with quantum awareness. As you breathe naturally, feeling the air enter and leave your body, you are experiencing the eternal present directly. This breath, this heartbeat, this moment of awareness is not separate from the timeless quantum processes that underlie all of reality. You are the universe experiencing itself in this eternal now, consciousness arising from and returning to the deathless source of all existence. And so we return, as all journeys must, to where we began, but we arrive with transformed understanding of what this place is and what it means to be here. The ordinary moment you inhabit right now, listening to these words, breathing quietly, feeling the subtle sensations that flow through your body, is revealed to be anything but ordinary. What we've discovered together is that reality, as we once understood it, was never real at all. Every solid surface you've ever touched, every colour you've ever seen, every sound you've ever heard emerges from a quantum realm where nothing exists in definite form until the moment of observation. The universe we inhabit is not a collection of objects, but an ocean of possibilities, constantly collapsing into experience through the mysterious act of consciousness itself. Perhaps the most profound realization is that you're not separate from this quantum mystery, but are its most intimate expression. Awareness arising from the very uncertainty that makes existence possible. Rest now in this wonder, knowing that every breath connects you to the infinite creativity of a cosmos that dreams itself into being moment by moment through the gentle miracle of observation.